to get to today. Want ons twee verskillende formules. Die een is om die krag uit te werk and the other one is to calculate gravitational acceleration. Because remember, gravitational acceleration is 9,8 meters per second on Earth, but it won't be that on planet X. Okay, so I want to get to those today, but I first want to establish these because these are the level 1 and 2 questions which I expect you to get. Okay, goed, so na al die drama, kom ons merk. Nommer 13 sê vir jou, two objects, A with a mass of 5 kilograms and B with a mass of 8 kilograms are 600 millimeters apart. Now, you will always get the formula, but I'm just going to write it down for you guys anyway. Now, what do I need to know about mass? Must be in kilograms. Are those given in kilograms? Hulle word inderdaad. So, M1 is 5, M2 is 8. Of andersom, whatever floats your boat. Nee? Wat weet ons van R? Dit moet wees in meter. Al gooi hy sy blaai reg, is hy reg hierdie keer. Weg, is hy reg. Wat ook al. Okay, so as daai 600 millimeter is, hoeveel meter is dit? 0,6 meter. Okay, do that first, guys, please. Okay, ek het nou nie 'n formule bly by my nie, anders kon ek vir julle 'n hint gewys het, maar ek sal dit nog vir julle wys. Okay, so I'm just going to substitute that. 6,67 times 10 to the power of negative 11. Jy skryf eers jou formule neer, moenie lui wees nie. En moenie jou blaaie weggooi nie. Okay, I'll get to that now. Thank you, Lydia. Oh, there is one in the back of your books as well. Onthou van daai kwadraat. And that gives you 7,41 times 10 to the power of negative 9 Newton. And it is an attracting force. Yes.
Yeah, whenever I did these sums, I wouldn't get times 10. I'd get a full answer.
That's something on your calculator. Quickly type this into your calculator. It's going to take a while, but quickly type that into your calculator. Okay, is daar nog een van julle wat dit nie in wetenskaplike notasie gee die antwoord nie? Dit is 'n setting op jou sakrekenaar. Okay. Goed, terwyl hulle besig is om te type en te test, by die volgende ene, hier het ons uitgewerk die krag van A op B, dink ek. Ja. Calculate the gravitational force that object A exerts on B. Now they say, what is the gravitational force that object B exerts on A? Exactly the same. Why? Newton 3. As ek vir jou vra om dit te verduidelik, moet jy vir my kan sê, Newton se derde wet sê, vir elke krag is daar 'n teenoorstaande krag, né? Wat ewe groot is, maar in teenoorgestelde rigtings is.
I got that. Which is weird. But the two songs that I did in the textbook,
I don't know. I posted the memo for the ones that you did in the textbook. So I don't know if those had a times 10 to the power of what. We'll get to those now. Because sometimes if it's not that big a number, they don't put it in.
I marked with Wolfman and she didn't have that.
But this one isn't that big a number. So that will only be a. Oh, but you got something.
Unless it was like
Yeah, but this number is.
she's attracted to the play because she had towards this one. Because this part was correct. And that's exactly what I did.
Het een van julle wat die huiswerk gemerk het 'n ander antwoord gekry by vraag 5?
I'm getting that one. I know I never run. And this was a few and then it continued into that. So.
Het een van julle dit gemerk van die memo af maar ander antwoord gekry? Okay, so now click on it. Your answer is correct and you don't have to write it in scientific notation. Because that's not that big a number. Times 10 to the power of 5 isn't that big a number. So you can write down as it is given on your calculator. But your calculator will give to the power of negative 9 as to the power of negative 9. Okay, goed. So we can all agree that this one will be exactly the same in magnitude. And it also attracts the other one. Okay, nou sê hulle vir ons, wat gaan die krag tussen die twee voorwerpe wees as die afstand tussen hulle halveer word en die massa van albei verdubbel word? So let's first see what happens to the force and then we'll apply it on the actual numbers. So they said that both of the masses will be doubled and the distance between them will be halved. So do you agree that that'll be 4 over a quarter? Right? In other words, it'll be times by 16. Okay, en as jy dit het, kan jy net gaan sê 16 maal daai 7,41 maal 10 to die mag min 9. If you did it, I almost want to say old school, and you literally went and doubled both the weights and halved the distance, you will get all your marks. Okay? Maar ek wil hê julle moet weet hoe om hierdie te doen, want as hulle dit vra soos wat hulle in die oefening gevra het, wat is die invloed as iets verdubbel word of iets halveer word, dan kan jy nie net gaan getalle manipuleer nie, dan moet jy weet hoe om uit te kom by maal 16 of deel 5 of wat ook al. Okay, so for this one the answer will just be 16 times 7,41 times 10 to the power of negative 9, which is equal to 1,19 times 10 to the power of negative 7 Newton, and it's still an attracting force. Okay. En ek het ook vir julle nommer 14 gegee. So they say the gravitational attraction force between two large submarines with a mass of 60,000 kilogram and 200,000 kilogram respectively is 0,0162 Newton. How far apart are the ships? So hierdie keer gee hulle vir jou die krag, hulle gee vir jou die massas, maar hulle vra vir jou om R uit te werk. So you have the force is equal to 0,0164. You have mass 1, hy is klaar in kilogram. Jy het massa 2 ook klaar in kilogram. Ja. En R is wat ons soek. So jy begin weer eens met jou formule. En ons stel in. En onthou dan om die vierkant wortel te kry. Let's check that I didn't mistype something. Good. Okay, this one is another example of how small the actual force, that results is. So hierdie is twee redelike swaar voorwerpe. Stem julle saam? And they are not far apart. In fact, they are worryingly close to one another. As twee submarines 7 meter binne mekaar is, dan kan jy net maar verwag dat hulle mekaar gaan vas. Okay. So in other words, they are very close to one another and they are very heavy. And do you see that they still only have a 0,0164 Newton force between them? En dit is hoekom ons sê mos alles het 'n krag op alles, maar dit beteken nie dat elke voorwerp besig is om te versnel na 'n ander voorwerp toe.
Hoe groot is 1 Newton? Hoe kragtig is dit?
Nicola, ek praat nou onder korreksie, maar dit is dieselfde as 1 kilogram. Ek gaan nou maar net seker maak daarvan, maar dit is die krag wat 1 kilogram wat van 1 meter af laat val is.
Wat is dit?
Ek kan nie onthou nie, maar jy kan kilogram omskakel in Newton. So I'll tell you now. Ek gaan nou vir jou kyk. Ja, met 10 dan. Ja, met 9,8. Okay, goed, maar ons sal nou maar 'n eksperiment daaroor soek. Okay, and then for 14.2 they say what will the force between them be if this distance doubles? So voordat ons hom uitwerk, gaan die krag toeneem of afneem? Will the distance increase or decrease? Hulle sê vir jou die afstand verdubbel. As jy jou papiere voor jou gehad, seker weet het. Ja, afneem. The further they move away from one another, the smaller the force becomes. Nee? Hoekom? Want die krag is omgekeerd evenredig aan die afstand kwadraat. Nie aan die afstand nie, omgekeerd evenredig aan die afstand kwadraat. So in other words, if r doubles, then it means it will change by a factor of a quarter. So wat gaan die nuwe krag wees? Die nuwe krag is nou 'n kwart maal 0,01. Nee, ek jok. Nee, ek is reg. Baie klein.